Section 1: Why evaluation-centric ML interviews are becoming the new standard. If you've been interviewing for ML or LLM roles lately, you've probably noticed something strange. Fewer questions about modeling, more questions about evaluating models. 2 years ago, interviews revolved around architecture's training pipelines feature engineering hyperparameter tuning theoretical ML concepts. But in 2025-2026, the conversation has shifted. Today, companies like Meta, OpenAI, Anthropic, Google, Tesla, and AI-first startups increasingly assess candidates based on how they measure model quality, how they design evaluation plans, how they detect failure modes, how they handle noisy, biased, or incomplete data, how they run ablations, diagnostics, and stress tests, how they evaluate LLM reasoning, hallucinations, robustness, and generalization. This is no longer a niche expectation. It is now one of the strongest hiring signals for senior ML and LLM engineers. Why? Because the bottleneck in AI has changed. The challenge today isn't training models, it's knowing how to evaluate them. Check out Interview Node's guide, Common Pitfalls in ML Model Evaluation and How to Avoid Them. Let's break down why the interview landscape has shifted so dramatically. A. Models are no longer the hard part. Data and evaluation. 10 years ago, modeling was the frontier. CNN architectures, RNNs versus LSTMs, transformer adoption, hyperparameter innovation. But today, everyone trains models the same way. Everyone uses similar frameworks. Everyone downloads the same pre-trained checkpoints. The hard part now is getting clean datasets, designing robust evaluation pipelines, measuring behavior under real-world conditions, diagnosing failures, building observability into ML systems. Companies want engineers who can do the one thing automated training pipelines can't. Think critically about what good performance actually means. B. LLMs introduced a new layer of complexity: behavior accuracy. Traditional ML tasks had clear metrics: accuracy, F1 precision, R recall, RMSE, ROC, AUC. You could measure quality in a single number. But LLMs introduced a new world: hallucinations, inconsistency, brittleness, safety, violations, stale knowledge, reward, hacking failure on edge cases, context length degradation, prompt sensitivity. Evaluating LLM quality requires multi-layer metrics, human in the loop, evaluation, rubric-based scoring, structured prompting, adversarial testing scenario. Based evaluation companies now hire engineers who can evaluate reasoning grounding, factual consistency, harmlessness, helpfulness, robustness. This requires judgment, not just math. That's why interviews now look for evaluation mindset more than modeling mindset. C. Evaluation has become a first-class engineering concern. Previously, evaluation was a footnote in ML pipelines. Now, it's a strategic priority. Companies learned the hard way that models fail silently, metrics hide problems, edge cases matter deployment, exposes blind spots offline evaluation, often predicts nothing. Production ML isn't about accuracy. It's about reliability, trust, transparency, robustness, consistency. This is why evaluation-centric engineers are becoming more valuable than modeling-centric engineers. D. Data-centric AI made evaluation the centerpiece of the workflow. Data-centric AI flipped the script: improve data, better model; improve evaluation, better understanding; improve both, fewer failures. Instead of optimizing architectures, companies now optimize labeling, quality, annotation, consistency, dataset coverage, edge case representation, distribution, alignment, evaluation, rigor. Because the industry realized great data beats clever architectures, great evaluation beats guesswork, great diagnostics prevent expensive failures. This is why interviewers increasingly ask, how would you debug this distribution shift? Design an evaluation suite for a summarization model. How would you detect data leakage? How do you measure hallucinations? These are evaluation first questions. Section 2. The core mindset of evaluation centric ML interviews. How senior engineers think about model behavior. The mental shift every ML engineer must make to succeed in evaluation first interviews. Most ML candidates approach interviews with the same mental model. I need to build a good model. But evaluation centric ML interviews test a completely different mindset. I need to deeply understand model behavior. This difference seems small, but it defines who passes and who fails in 2025-2026. Because evaluation first interviews aren't asking, can you train a transformer? Can you fine tune BERT? Can you build a classifier? They're asking, do you know what good looks like? Do you know where the model will fail? Do you know how to test it under real world conditions? Do you know how to diagnose misbehavior? Do you understand data coverage? Do you know how to design metrics responsibly? This is why the highest leverage skill for senior ML interviews is not modeling, it's evaluation thinking. Check out Interview Node's guide, The Hidden Metrics, How Interviewers Evaluate ML Thinking, Not Just Code. Let's break down the evaluation first mindset into the core components interviewers are actually testing. A. Evaluation centric engineers start with questions, not models. A modeling centered candidate says, we can try X architecture. An evaluation centered candidate asks, what failure modes matter most for this product? What does success mean for this user? What constraints shape the evaluation criteria? What behaviors are unacceptable? This is a fundamentally different mental model. Interviewers are listening for curiosity, skepticism, sharp problem definition, alignment with product context. When you start with questions, not solutions, you immediately sound more senior. B. They treat the model as a behavior system, not a function. Traditional ML treats models like mathematical functions. Evaluation-centric engineers treat models like behavioral systems. They care about consistency, robustness, fairness, stability, contextual sensitivity, generalization, safety failure, characteristics. This mindset is mandatory for LLMs, where outputs are probabilistic, contextual, multimodal, non-deterministic, sometimes wrong very confidently. An evaluation-centric engineer thinks like a scientist observing a phenomenon. Instead of asking, how accurate is my model? They ask, how predictable is my model's behavior across different conditions? Interviewers love this. C. They understand that metrics are opinions, not truths. Senior interviewers expect you to understand. A metric is a compressed opinion about reality. Every metric encodes assumptions, reflects priorities, hides some behaviors, amplifies others, is vulnerable to manipulation. Evaluation-centric candidates demonstrate awareness of this. For example, accuracy hides class imbalance issues. Blue score doesn't capture semantic quality. Rouge exaggerates surface-level overlap. Hallucination rate depends on evaluator strictness. F1 score is unstable on small data sets. Interviewers aren't testing memorization, they're testing judgment. D. They separate model performance from data quality. Mid-level candidates blame the model. Senior candidates investigate the data. When an interviewer shows you mispredictions, weird errors, drift behavior distribution shifts, inconsistent outputs, a junior candidate says, let's tune the model. A senior candidate says, let's examine the data distribution, labeling consistency, annotation policy, and feature coverage. This is why data-centric AI is the new center of gravity. Evaluation-centric engineers understand labeling noise annotation, drift coverage gaps, slice-level failures, ambiguous instances, systematic errors. This is the level of rigor senior interviewers want to hear. E. They know that evaluation is a multidimensional space. Evaluation isn't a single score or metric. It's a coordinated set of signals, including model-level evaluation, accuracy, F1 loss curves, confidence calibration, sensitivity analysis, data-level evaluation label, consistency, distribution, alignment, edge case coverage, slice analysis, imbalance, system level evaluation, latency throughput, robustness, reliability, degradations over time, product level evaluation, user trust, safety relevance, quality of experience. Evaluation centered candidates weave these layers naturally into their explanations. They speak in dimensions, not metrics. Section 3. The 10 evaluation skills you must master and how interviewers test each one. A blueprint of the exact competencies companies like Google, OpenAI, Anthropic, Meta, Tesla, and AI-first startups now measure in evaluation-centric ML interviews. Evaluation-centric ML interviews are not open-ended creativity tests. They are extremely systematic, highly diagnostic, and rooted in identifying whether a candidate understands model behavior deeply and responsibly. The following 10 evaluation skills form the foundation of modern ML interview loops. These skills directly correlate with real-world ML reliability and reflect what senior ML engineers do day to day. Below, you'll learn each skill, why it matters, how interviewers test it, and what great answers sound like. Check out Interview Nodes Guide, Comprehensive Guide to Feature Engineering for ML Interviews, A. Metric Design and Interpretation. Can you measure what matters? The first skill interviewers evaluate is whether you can design, critique, and select metrics that actually reflect the true goals of the product. Interviewers test this through questions like, how would you evaluate a summarization model? Why might accuracy be misleading? Design a metric for hallucination reduction. What metric failures have you seen in production? What strong candidates demonstrate? Awareness that every metric encodes assumptions ability to combine multiple metrics, product plus statistical plus safety, ability to critique common metrics, blue, rouge, accuracy, F1 understanding of calibration, ranking metrics, and long-tail sensitivity. This skill alone separates junior candidates from senior ones. B. Slice-based evaluation and subgroup analysis. Can you find failures hidden behind a high-level metric? Models look great until you break down performance by demographic group, geography device, type, linguistic variation, rare categories, noise levels, long-tail classes. Interviewers test this by asking, how do you ensure performance is consistent across user segments? What slices would you define for a fraud detection model? What great candidates show? Skill at detecting silent failure zones. Understanding that aggregate metrics are misleading ability to prioritize high-impact slices. Slice-based evaluation is central to fairness, safety, and robustness. C. Label quality analysis and noise detection. Do you understand that poor labels, poor models? Data-centric AI places enormous emphasis on annotation consistency, labeling drift, ambiguous examples, inter-annotator disagreement. Interview questions include, your model is underperforming. How do you check if the labels are correct? What is annotation drift and how do you detect it? Strong candidates know how to check label entropy, how to build reviewer disagreement matrices, how to resolve ambiguity with rubric design. This is a core skill for LLM evaluations, where labels often come from human raters. D. Robustness and stress testing. Can your model survive real-world chaos? Real-world data is noisy, messy, incomplete, adversarial, distributionally different. Interviewers test this with, how would you stress test a toxicity classifier? How do you evaluate robustness to perturbations? Candidates must discuss synthetic noise injection, boundary case augmentation, paraphrase testing, adversarial prompts contrast sets. This communicates maturity and safety-oriented thinking. E. Data drift detection and monitoring. Can you detect when your model becomes wrong? Evaluation isn't just offline. Senior engineers must monitor ongoing behavior. Common interview questions. How would you detect concept drift? What's the difference between data drift and model drift? Strong candidates think about embedding drift KL divergence of features, shift in label distribution time-based slice analysis, retraining triggers, interviewers reward candidates who understand long-term model health. Section 4, How to Practice Evaluation Skills, a step-by-step, 6-week training plan for ML interviews. A structured, data-centric preparation roadmap to transform you into an evaluation-first ML thinker. Evaluation-centric ML interviews aren't something you can cram for. They require depth, clarity, judgment, and a new way of thinking about model behavior. Most candidates fail because they try to memorize evaluation tricks instead of building evaluation instinct. This section gives you a 6-week structured roadmap that trains your brain to think like the people who design and evaluate real production ML systems at Meta, Google, OpenAI, Anthropic, Tesla, and top AI startups. This plan mirrors the internal training flows used in top ML organizations and helps you develop the competencies interviewers expect. Check out Interview Node's guide, The AI Hiring Loop, How Companies Evaluate You Across Multiple Rounds. Week 1, Build Your Foundation, Metrics, Slices, and Data Quality. Goal: Understand the basics of evaluation deeply enough to explain them with clarity under pressure. What to learn: Atomic metrics, accuracy, F1, ROS, AUC, blue, rouge, perplexity, calibration metrics. Strengths, weaknesses of each metric. Slice-based evaluation, demographics, geography, class-based, long-tail analysis, data quality principles, annotation noise, inconsistencies, ambiguity types. Drills, pick one ML task daily. Classification, regression, summarization, toxicity detection. Write out the best metrics plus why each metric may fail. Choose 3 slices and hypothesize potential failure modes. Take a public dataset, e.g. IMDb, Safer, Yelp, and analyze label noise manually. Outcome: by the end of week 1, you should be able to explain why accuracy is useless in at least 5 contexts, a core evaluation signal. Week 2, error analysis, failure typing, and root cause reasoning. Goal: develop the scientific instincts interviewers look for. What to learn: how to categorize errors into meaningful buckets, how to detect pattern-based failures, how to differentiate model-level versus data-level issues, how to generate hypotheses for misbehavior. Drills: take a model, any Kaggle model or HF model, and collect 50 to 100 errors. Categorize them into failure families, e.g., negation, sarcasm, multi-label confusion. For each category, ask, what feature or data property causes this? What evaluation gap allowed this behavior? Present your findings as if you were explaining them to a PM. Outcome: you now think like someone who runs high-quality ML evaluations, not someone who just trains models. Week 3, robustness, stress testing, and adversarial behavior. Goal: build instincts around stress testing and robustness analysis. What to learn: noise injection, perturbation testing, adversarial prompting for LLMs, context length degradation, input boundary failures, randomization sensitivity drills. Take any model and perform stress tests. Add spelling noise, change sentence structure, replace entities, add distractor tokens, increase context length, add adversarial prompts, measure performance changes. Document robustness gaps as if preparing a research note. Outcome: you become skilled at uncovering vulnerabilities, one of the strongest senior-level interview signals. Week 4, LLM, specific evaluation, hallucinations, reasoning, and safety. Goal: develop LLM evaluation intuition, the hottest skill in interviews today. What to learn: types of hallucinations, grounding checks, long context reasoning failures, multi-step chain of thought evaluation, safety violations, content filtering and alignment criteria. Drills: evaluate an LLM daily on factual QA reasoning puzzles, safety prompts, multi-step logic, score outputs using a rubric you design yourself. Identify hallucination patterns and explain why they happen. Practice evaluating chain of thought quality without relying on correctness alone. Outcome. Interviewers see you understand behavior, not just output correctness. Week 5. Experimentation, ablations, and scientific rigor. Goal. Learn to design experiments that isolate variables and validate hypotheses. What to learn? Controlled experiments, fixed versus randomized testing, parameter, isolation, impact, quantification, statistical significance, designing clean ablations, drills, pick a model and perform one dataset ablation, one feature ablation, one hyperparameter ablation, analyze results using confidence intervals, multiple seeds, data variance controls, present findings in a 5-sentence summary using clear style structure. Outcome. You now have the scientific discipline interviewers associate with staff-level ML engineers. Week 6. Put everything together. Full evaluation suites and mock interviews. Goal. Synthesize all skills into a unified evaluation strategy. What to learn? Designing end-to-end evaluation pipelines, building multi-metric evaluation dashboards, monitoring models across time, designing guardrails and fallback behavior, evaluating product impact drills. Choose one ML task, e.g., summarization, classification, retrieval, safety. Build a full evaluation plan including metric slices, failures, stress tests, hallucination tests, ITL, evaluation monitoring plan. Do 3 mock interviews focusing only on evaluation reasoning failure analysis, metric design assumptions trade-offs. Practice answering with the clear framework to maximize clarity. Outcome. You become interview ready, not because you memorized answers, but because you developed evaluation instincts. Conclusion. Why evaluation-centric thinking is now the ultimate differentiator in ML interviews. The ML world has shifted from a model-centric era to a data-centric, evaluation-driven era, and hiring pipelines have evolved accordingly. Companies no longer differentiate candidates based on who can tweak architectures or tune hyperparameters. Those skills are abundant, automated, and increasingly commoditized. What companies desperately need are ML practitioners who understand how models behave, why models fail, how evaluation frameworks should be designed, how to uncover hidden failure modes, how to build trustworthy systems, and how to align technical success with product impact. This is why evaluation-centric ML interviews now dominate loops at Meta, Google, OpenAI, Anthropic, Tesla, Microsoft, and AI-first startups. These companies hire not for how creatively you can build models, but for how rigorously you can measure, stress test, and critically analyze them. Because production ML isn't a science experiment, it's a reliability challenge. And reliability depends entirely on evaluation. Evaluation-centric thinking shows interviewers that you can reason scientifically, think with clarity under ambiguity, define metrics that matter, diagnose real-world failures, prevent safety issues, collaborate with non-ML stakeholders, and build systems that scale gracefully over time. FAQs, Evaluation-Centric ML Interviews 1. Why are companies prioritizing evaluation skills over modeling skills now? Because modern ML systems, especially LLMs, behave unpredictably. The bottleneck isn't training models, it's understanding and controlling their behavior. Evaluation is the new competence. 2. Do I need deep research experience to succeed in evaluation-centric interviews? No. You need judgment, rigor, and structured thinking. Many strong candidates succeed without research backgrounds because evaluation is about reasoning, not academic depth. Third, what is the most important evaluation skill interviewers look for? Clear failure mode identification. If you can articulate where and why a model breaks, interviewers immediately see you as senior level. Fourth, how do I practice evaluating LLM hallucinations? Run small experiments daily with prompts that test reasoning, grounding, context length, logic, and factuality. Score outputs with a rubric you design. Evaluation is learned through iteration. 5. Should I memorize metrics and formulas for interviews? Memorizing helps slightly, but interviewers are testing whether you understand why metrics fail, not whether you can define them. 6. What's the best way to demonstrate evaluation thinking in ML system design interviews? Always include slice-based metrics, robustness tests, monitoring plans, drift detection, and guardrail systems. This instantly shows you're thinking beyond raw modeling. 7. How do evaluation-centric interviews differ between FA-ANG and AI-first startups? FA-ANG focuses heavily on long-term reliability, drift, and safety. AI-first startups focus more on rapid iteration, debugging, and product alignment. Both require strong evaluation instincts. 8. How often do evaluation questions appear in real ML interviews now? In 2025-2026, nearly 70-80% of on-site ML loops include at least one evaluation-heavy round, sometimes more than one. 9. Can I prepare for evaluation questions without access to large models? Absolutely. You can practice with open-source models, Kaggle datasets, and structured rubrics. Evaluation skill is independent of model scale. 10. What's the quickest way to stand out in evaluation-centric interviews? Use this sentence early in your answer. Let's think through the failure modes first. It signals judgment, rigor, and senior-level awareness instantly.